Welcome to Module 7 of, we're going to cover probability a little more. Here we're going to talk about the basic properties of this probability. So for instance, in case you come to a possibility that the probability of an event A is equal to 1, then basically that event A must occur with certainty. So for instance, if Deb is buying a pair of shoes tomorrow, and she is very certain about it, because the day after tomorrow she has an interview, so she has to buy the pair of shoes. So in that case, the probability of Deb buying a pair of shoes as an event should be equal to 1, because it is for certain. Suppose that Deb buys her shoes tomorrow, the next day is an interview day. On that day, the probability of Deb buying his shoes as an event should be equal to 0, simply because Deb has already bought the shoes and she's going to be attending the interview that day, so she's not going to buy the shoes. So that is also a basic certainty. So if probability of A is equal to 1, then the event must occur with certainty. And if the probability of an event equal to 0, then the event will not occur with certainty. The probability of an event must be always between 0 and 1, including 0 and 1. The probability of it can be between 0 and 1. The sum of probabilities for the events in the same sample space must be equal to 1. For instance, if you flip a coin, we have two possible outcomes. The one event is going to be getting a head. The other event is going to be a tail. The events A and B represent the entire sample space. Okay, then the probability of event A, which is a head, plus the probability of event B, which is a tail, is going to be half plus half equal to 1. So the sum of probabilities for the events in the sample space must be equal to 1. So there is another way of looking at this probability, which is called the complement of event A. So the complement of event A is going to be denoted by A prime. So let me get my pen. Come on. If the probability of A, the complement of probability of A is going to be A prime. In that case, the probability of event A occurring plus the probability of A prime occurring is equal to 1. Or probability of A is equal to 1 minus the probability of A prime. Let's take the rolling of the dice one more time. So in this case, let's take 1 dice. Instead of 2, it's simple. So let's take 1 dice. The sample space of 1 dice is basically 6, which is 1, 2, 3, 4, 5, 6. If we want event A as rolling a 1, so if you want a 1 as the event A, then the event A prime is not 1. So if you want 1 as event A, the event A prime is not 1, which is 2 or 3 or 4 or 5 or 6. So the probability of event A is how many outcomes we have? Only 1. How many sample space we have? 6. So 1 over 6, which is 0.167. The complement of that will be 1 minus 0.167, which is 0.833. So if you want a dice of 1, 83.83% of the time, you are not going to get a 1. Okay, so that's the whole idea. Now we'll talk about intersection. Intersection and unions are important parts of events because here we can combine. So many events. So far we have been looking at only one event. Now we can combine other events. So let's take this. I have a friend and he has 3 kids. The first child's name is Deb, second child's name is John, third child's name is Brian. So when my friend gets calls, it's either on a crisis mode or a non-crisis mode. For instance, a crisis mode will be one of his kids will want some money, or they'll say, I need you to pick me up from school. Those are the crisis ones. Non-crisis would be, hey dad, how are you? That kind of a call. So if I take these calls, and my friend what he did was he counted the number of calls which are crisis and counted the number of calls which are non-crisis over a period of time. And then he put it as a table like this. So this is my data. Okay. He wanted to know. So he called me and says, I have this table of events. Now tell me, what will be the probability of the next phone call that is coming from Deb? So what is the probability that Deb will call me next, or the next phone call will be from Deb? So at that time, all I do basically is to look at this table. I'm going to look at the outcomes. The outcomes of Deb calling will be both crisis and non-crisis, which is going to be equal to 20. So 20 will be my total outcomes. The total sample space is 50 because that is what he has collected. So 20 over 50, which is 0.4, is the probability that the next phone call will be from Deb. So my friend asked me, okay, what is the next phone call that will involve a crisis? If I'm going to do the crisis, I have to take all these things together. That means my total outcome is 28. This is a crisis call. It's going to be crisis not only from Deb, but also from John and also from Brian, because all of them are crisis calls. So my total outcome is 28. My total sample space is 50, so that is going to be 56% or 0.56 is the probability that event B, which is the next phone call, will involve a crisis, is going to happen. Okay, so this is a part of intersection. Now, intersection of events can be said as, or can be denoted as A intersection B. So this A intersection B is the symbol like this, A intersection B. Okay. So if I want to know the probability that the next phone call will come from Deb and will involve a crisis. Now we are having 2 different events. One is an event A, the phone call from Deb. The event B is a phone call which is a crisis. So look at it this way. The phone call from Deb and involve a crisis is going to be just this, 14. That is the intersection. It's the intersection that Deb is going to call and it is going to be a crisis call. So we're not going to include the non-crisis here. We're going to include only the crisis because it says and a crisis, a Deb and a crisis. So the probability of A and B occurring is going to be equal to 14 over 50, which is the sample space, which is 0.28 or 28%. So 28% of the time is what we are talking about. A 28% probability that the next phone call will be a crisis call from Deb. That is a call from Deb and will involve a crisis. Okay, that is 28%. Okay, so let's do union next. Now, the union part of it is just the opposite of intersection. So here we're going to use an or instead of an and. That's the basic difference. Okay, I have the same data. I'm going to find out what is the probability that the next phone call is either from Deb or is a crisis. So in this case, the phone call can be from Deb, or a phone call can be a crisis phone call. That means John's crisis phone calls, Brian's crisis phone calls has to be taken into account. So the total calls, the total outcome will be all the phone calls from Deb, because I said either from Deb. So all the phone calls from Deb, or the crisis calls from Deb, John, and Brian. So that means I need to involve these numbers, which will be either call from Deb or all the crisis calls. So the total outcome will be 14 plus 10 plus 4 plus 6, which is going to be 34. Okay, and that will be the possible outcomes. And the total sample space is going to be 50. So 34 over 50, which is 68.68, is going to be the probability of the union. The union basically is done this way. A union B is denoted this way. The intersection is going to be just the opposite of this U. Okay, so the probability of A or B, which is the P of the probability of A union B, is going to be 0.68. Okay, so there is 68% probability that the next phone call is either from Deb or is a crisis. Okay, so with this we'll go to module 8.